Hello everyone, I am Madhuri, working as Assistant Professor in the Department of EEE at MLR Institute of Technology, Hyderabad. I am going to discuss about this course DC machines. So today I am going to start with the introduction to the course. Why particularly this course DC machines? This is a very fundamental course, the stream of electrical engineering. So in this, by the end of this course, we will be able to understand the fundamental concepts of what is an electromechanical energy conversion principle and what are the various laws concerned with electromechanical energy conversion in this course. And this course also help you to understand how the magnetic fields are generated in various machines and how the torque is produced in the various machines and how is the EMF generated in various machines and what are the respective mathematical expressions involved in all these three terminologies. And then it also forms the foundation for next level of machines, that is nothing but AC machines and the modern drives. And the main objectives of this course, by the end of this course, all the concepts listed here will be discussed detailedly. So first topic is about different types of DC machines. What are the different types of DC machines? And also we will be studying about what are transformers in detail. Types of DC machines basically categorized into DC motors and DC generators, under which we'll be studying about the working principle, their construction and their efficiency calculation, what are the losses, what are the respective performance characteristics of the various machines. We will be clearly studying under the topic of DC machines. And in this, we will also be studying about the transformers, the working principle of transformers, construction of transformers, and how the EMF is generated in the core of the transformer and what is the efficiency calculations of the transformer and what are the various tests performed on transformer to calculate its efficiency. And then we'll be detailedly studying about the electromechanical energy conversion principle and what are the various laws involved under this electromechanical energy conversion principle and the respective mathematical expressions there will be studied clearly under electromechanical energy conversion topic. And then moving on to the performance characteristics of various DC generators and DC motors. As discussed, the DC machines are nothing but we will be clearly studying about the DC generators and DC motors. So what are the performance characteristics? Mainly, we will be studying about the speed, the torque, the voltage and the current, and the respective relation between all these four terms in detail for different DC generators and different DC motors in this course. Then moving on to the next topic, we will also be studying about the losses in DC machines. Again, DC machines concerned about DC generators and DC motors. So we will be studying about what are the various kinds of losses and how does that affect the efficiency of the machine will be discussed detailedly. Then again, we'll be moving on to the efficiency calculation through various performance tests. What are the various tests involved in calculating out the efficiency of any particular machine, whether it may be a DC generator or a DC motor. Then moving on to detailed discussion about the principle of operation, construction, and the testing methods on single phase transformers. We also have three phase transformers, but under the course of DC machines, we will be studying about single phase transformers, its respective principle of operation, the construction and the various testing methods to calculate the efficiency of the single phase transformers. Moving on to the final topic of the DC machines course, we will be studying what are the real-time applications of DC machines in today's world. These are the main objectives of this course. Moving on to the first basic definition of what is an electrical machine. So electrical machine is nothing but a link between an electrical system and a mechanical system. Electrical system, your inputs may be voltage and current. For the mechanical system, your inputs may be the torque and the speed. So the link which forms between the electrical system and the mechanical system is nothing but your electrical machine. So electrical machine can be DC machine and an AC machine. So now we are discussing about the DC machines. So conversion of this mechanical energy into electrical energy is a function of an generator. So converting the given mechanical input to the electrical output is done by a generator. And the principle of operation of motor is quite reverse to that of the generator. We will give the electrical input here and it will be converted to the mechanical output in the motor. So these basic differences between a generator and a motor. Here we can see the classification of the machines. So basically your electrical machines are classified into DC machines and AC machines. In DC machines we have generators and we also have DC motors. As discussed in the learning objectives, we will be clearly studying about their types, construction and working principle under DC machines topic. And we also have other classification, AC machines. AC machines are broadly of two types, synchronous machines and induction machines, which will be the next level of topic after the DC machines. So we know from the name itself, AC machines, the electrical system is nothing but the AC alternating system, and the DC machines, the electrical system is nothing but the DC. It always deal with the direct quantities, and AC machines deal with the alternating quantities. So moving on to the first topic in DC machines, we will be seeing about the construction of a DC machine. The construction of DC generator and a DC motor is very much similar. It is similar. That means studying about the construction of a machine, DC machine, will give you the construction of both DC generator and a motor. So only the difference comes with respect to the input and output of your generator and motor. This is the cut view section of a DC machine. You can see this is the outer part. This is a rotor. The name itself indicates it's a rotor. We can see the armature winding. These are the various parts of the DC machine. We can see the permanent magnets, which produces the magnetic field in the DC machine. Here is a cooling fan. Whatever the heat is produced during the current flow in the DC machine is cooled up by this cooling fan, the commutator and the brush assembly. So we'll be discussing in detail about all the constructional parts of a DC machine in the coming slides. Moving on to the next slide. This is a schematic diagram of a DC machine. Here you can see the poles, North Pole and South Pole. In DC machines, we use electromagnets to produce the magnetic field in the machine. So coming to the various parts in the schematic diagram, we can see a field winding, we can see pole shoes, we can see yoke or frame, we can see the commutator, we can see the interpoles, we can also see the armature conductors and the shaft. Shaft is the iron rod on which your entire DC machine is mounted. So this shaft will be supported by bearings on both the ends to avoid the frictional losses. So in the further slides, we will be discussing about all the parts of the DC machine in detail. Moving on to the first main parts of a DC machine. First one is stator and a rotor. Stator, the name itself indicates it is a stationary part of a machine, yes, which is static, and this stationary part of a machine will house all the field windings, all the poles and all the other remaining machinery inside the DC machine, all the parts inside the DC machine. Rotor, the name itself indicates it is a rotating part in a DC machine. So all the rotating parts and the magnetic field will be generated in the rotor, and the current and EMF will be also induced in this rotor current carrying conductors. So what is a stator and what are the parts in the stator, and what is a rotor and what are the parts in the rotor, we'll be seeing in the coming slides. So first and foremost part is nothing but your yoke. Yoke is nothing but the outer covering of a machine. Outer covering of a machine. It is the material used for making the yoke is nothing but the cast steel. It protects the internal machine parts like armature windings, field poles from the external mechanical damages and also from moisture and dust. This yoke houses the magnetic field system, which is nothing but the main poles, interpoles, and also the windings on the poles, which is nothing but the field windings. So this yoke will be a protection for all the parts inside a DC machines, which protects us those internal parts from moisture, dust, and the mechanical damages. And this yoke provides the low reluctance path for the working magnetic flux. The magnetic flux will be generated by the magnetic poles when the field winding is excited through the external supply. So this yoke provides a low reluctance path so that the working magnetic flux in the DC machine will be moving throughout the frame without causing any losses. It supports the rotor armature through bearings. Rotor armature is nothing but your rotating part of the DC machine. It supports this armature through bearings. So this is yoke. You can see a terminal box here. This is a handle to lift the yoke. This is the outer frame, and these are the legs which support the yoke of the DC machine. So the main outer frame of your DC machine is nothing but yoke. It is made up of cast steel. It houses all the internal parts of a DC machine. It protects the DC machine's internal parts from the outer mechanical damages, moisture, and dust. It also houses the magnetic field system, and it provides a low reluctance path for magnetic flux. Next comes the field system. Field system is housed in the outer frame, that is nothing but yoke. So in the field system, we can see the electromagnets upon which your field winding is wounded. In this is the main field system provides the working magnetic flux in the DC machine, which is again responsible for production of EMF in the DC machine. So there are basically main three parts in your machine in the field system: pole shoes, pole core, and field coils. So pole core is nothing but the actual electromagnets used in the DC machine. Pole shoes are nothing but the extended outer structures. These are nothing but the extended outer structures to support your pole core, and the field windings are wounded on your pole core. The field windings are made up of copper wire. The field winding is first inserted around the pole core, that is nothing but it is wounded on the pole core, and this pole core is laminated to avoid eddy current losses in a DC machine. So what are eddy current losses will be discussed under the topic of losses in a DC machine clearly. And the pole core is made up of thin steel laminations. These laminations are nothing but to avoid these losses. This pole shoe, which is projected, will have a larger cross-sectional area to provide a uniform path for the working magnetic flux to be flowing in the outer part of a DC machine. So this is about the field system, which basically consists of three main parts: pole core, pole shoes, and field coils. So these field coils are made up of copper wire. These field coils are wounded on pole core. These pole cores are mounted on pole shoes. So this entire field system will provide the working flux and also uniform path for the flow of low reluctance magnetic flux in the outer frame of a DC machine. Next comes to the armature. Armature is nothing but the rotating part of your DC machine. In DC machine, this is nothing but the armature. You can see a toothed structure in the armature rotating part. So we have laminations in this tooth structure. These laminations are again to avoid the losses in this rotating part of the machine, that is nothing but armature. So armature mainly consists of two parts, armature core and armature winding. So armature core is nothing but, this is nothing but your armature core. The windings which are wounded in the slots are nothing but your armature windings. It is a solid cylindrical structure which we can see from here, which is made up of high permeability silicon steel laminations. Again, the laminations here are to avoid or reduce the eddy current losses in this rotating part of the machine also. Then, in this slots, the armature winding, which is made up of copper, is wounded, in which the working torque and the EMF is generated in the armature coils. Depending upon the connection of these conductors in these toothed slots, the windings is of two types, lap winding and wave winding, which will be discussed in the further topics very clearly. So we can see here this material, which is in brown color, made up of copper, are nothing but your armature coils, and this is nothing but the laminated armature core. This is the front view of this, and this we actually see when we cut through a machine, and this is visible when we see inside a DC machine. So these are nothing but armature core, and these are nothing but the armature conductors, which actually carry the current in the armature. So coming to the armature, in short about armature, it is a rotating part of the machine. It is a solid structure, solid cylindrical structure, which have tooths in it. These armature core is laminated to avoid the eddy current losses, and there are also air ducts in the armature core to reduce the heat produced by the armature windings in the armature core. To reduce the heat loss, we have air ducts on the periphery of your armature slots. The working torque and the EMF are generated in the armature coils, and based upon the connection of your windings in the armature core, it is of two types. We have two types of winding, lap winding and wave winding. Next, coming to the commutator. Commutator is one of the most important parts in a DC machine. The actual function of a commutator, it acts as a rectifier. It converts the input AC signals, the AC signals generated in the rotating part of the machine, that is armature, into the unidirectional DC signals. So it acts as a mechanical rectifier, and it is also a cylindrical structure which is made up of copper. Mechanical rectifier, we know that a rectifier converts an input AC to a DC. So converts the input AC induced from the armature windings into DC at the outer terminals of a DC machine. So in armature, we can see a segmented copper bars which are insulated from each other by a material called mica, or in some machines we find plastic insulation also between the copper bars in the commutator. So again, this commutator is connected to brushes. So the current which is produced, the DC current which is produced in the commutator, is passed to the external circuit with the help of brushes. So commutator is nothing but a cylindrical structure which collects the current from the armature. It converts the AC current which is passed on from the armature to a unidirectional DC current, and in turn it gives it to the external terminals of an DC machine. Next, moving on to interpoles. Interpoles are the poles which are connected between the main poles of a DC machine. So the main, again, there is a winding which is wound on the interpoles. We can see on the picture, which is nothing but interpole winding, and this interpoles are laminated with soft iron. So these interpole windings are connected in series with armature winding. These interpoles, you can see this is the outer part, which is nothing but the yoke. It is mounted on yoke, and it is positioned in midway between the two main poles of a DC machine. So the main function of interpoles is to improve the commutation process, that is the process of conversion of AC signals to DC signals, and also it is used to reduce the sparking at the brushes in the process of current reversal in a commutator. In the process of conversion from AC to DC in a commutator, there is a current reversal which produces sparks at the brushes. So these interpoles will reduce the sparking at the brushes. In turn, it improves the process of commutation. The main function of interpoles is nothing but it reduces the sparking at the brushes, and it overall improves the process of commutation in the DC machine. Moving on to the next constructional part, it is about the brushes. These brushes form as an electrical connection with the rotating commutator. So whatever the current which is passed from the commutator, it is collected by the brushes and it is delivered to the external circuit by these brushes. So brushes are usually made up of carbon material in heavy machines, and in small size machines they are made up of graphite. So the main function of the brushes, it will be collecting the current from the commutator and it will be delivering it to the external circuit. Brushes are usually made up of carbon material. Based upon the function of a DC machine, when the DC machine works as a motor, and the DC machine works as a generator. Based upon the inputs and outputs of the terminals, these brushes are also acts as, it can collect the current and at the same time it can supply the current based upon the function of the DC machine, if it is functioning as a DC motor or a generator. Based upon the functioning of a DC machine, these brushes operate accordingly with respect to motor and generator functioning. And the last constructional part in a DC machine is nothing but bearing. So bearings are fixed at the ends of the shaft in a DC machine. The shaft is upon which your rotating part and entire the machine is housed on the shaft. So the shaft is protected with the help of bearings. To avoid the frictional losses in the machine, we use bearings. We said that bearings also support mechanical shaft with minimum friction. And types of bearings which are used in a DC machine are nothing but ball bearings and roller bearings. So these are mainly used to reduce the frictional losses in the machines, whether it may be a DC generator or a DC motor. This is detailedly about the constructional parts of a DC machine. So in this topic, we have seen about the introduction to our DC machine course. We have seen what is an electrical machine. We have seen what are the types of electrical machines. We have also seen the construction of a DC machine, and we have also discussed detailedly about the various parts of a DC machine. Thank you.